Okay, this is section 1.2, linear equations in one variable. This is not a review section. This is a section that you need to know how to do. So the first thing that we're going to talk about are these two properties of equality. And everybody knows about this. So basically, if you add a number on one side of the equation, well, you have to balance it out and add it to the other. If you multiply one side of the equation by a number, then you have to multiply the other side by the same number. Now, remember I told you earlier about um, these properties are only based on addition and multiplication, but we can sneak in, for addition, we can also sneak in subtraction, and for multiplication, we can also sneak in division. And the way that we do that is if I were to add a negative number, adding a negative number turns out to be the same thing as subtracting. Okay, but we are adding a negative number, so it does follow the addition property of equality. For the multiplication property, I could multiply by a fraction, which would end up being a division scenario. Okay, but it's still, bottom line, it still is going to be multiplication. So when we look at number one, x over 16 equals 0.4. If I want to solve for x, I notice that x is being divided by 16, so I want to undo it. So I need to get rid of the 16. So I'm going to multiply both sides by 16. And so when we do this, our 16s are going to reduce. So we get x equals, and then 0.4 times 16 is, let's see, well, 4 times 16 is 64 with one decimal, so that's going to be 6.4. Now, that is our solution, but Alex is going to want you to leave your answer in set notation, and set notation is when you write your answer inside the set of braces, okay? So be careful how you leave your answer. Now, number two, negative 18 equals 40 plus z. I want to solve for z, so the 40 is in my way, so I need to get rid of the 40. So I'm going to subtract 40 from both sides. And so we end up with a negative 18 and a negative 40 is a negative 58 equals z. Whoops, I didn't mean to start blocking that in. Now, if this were a paper, if this were a test that I were giving you, I would be perfectly fine with you giving me this answer and then just blocking it in. But because you're going to be answering these questions in ALEKS, it's going to want the set notation. So you need to get in the habit of writing your answer inside the set of braces. Okay. Now, number three, we have 4/9 x equals negative 5/18. So if the 4 happened to be a 1, then I could just multiply both sides by 9. And then I would solve for x. And if I had 4x equals the negative 5/18, then I would divide both sides by 4. So because we have this fraction, the way we can get rid of it in one step is to multiply by the reciprocal. So I'm going to multiply both sides by, that looks like 4 over 4. I'm going to multiply both sides by 9/4. Okay, that's the reciprocal of the coefficient in front of my variable. So these guys will reduce. So we get x equals, now negative times a positive is a negative. And so we're going to be able to reduce. 9 goes into 9 once and goes into 18 twice. So now when we multiply fractions, we multiply straight across. So 5 times 1 is 5. 2 times 4 is 8. So my answer is the solution set, negative 5/8. Okay. All right. So those are one-step equations. Now, when we look at multi-step, there are several things that we need to take into consideration. So step one, the first thing that you want to do, and you need to think of this as one big cleanup. So we're going to clean up both sides. And so what we mean by this is the way we clean up both sides is we need to remove any parentheses that are present by using the distributive property. Then we're going to combine the like terms on each side. And let me write this in on each side. Okay. Now, if you have fractions or decimals, if you have fractions, you can multiply through by the LCD. If you have decimals, then you multiply through by the greatest number of decimal places. Okay. Step number two is when we use the addition property of equality. This is when you start moving terms from one side to the other. So you would move your variables to one side and then your constants to the other. Now notice that I don't do that up here in step one. In step one, I want to clean up each side first. And the reason why is when you start moving too many terms around, sometimes you inadvertently forget about a term, or you end up combining terms. You make a small error when you combine terms. So you want to, or I'm sorry, you end up making a small error as you start moving things around. So you definitely want to clean up each side first. Then you apply the addition property. So you move things around from one side to the other. Step three, you use the multiplication property in order to get x by itself. Then number four, the solution that you get, it's a potential solution. So you want to check, you want to plug that back into the original equation. And if you end up with a true statement, then you know it's the correct answer, and then you write your solution set. Okay, so the solution set, let me write this up here. Your solution set means that your answers are in braces. Now, the reason why I said answer or answers is sometimes when we solve certain types of equations, we may end up with more than one answer. Okay. So remember, Alex, when you work on your homework, Alex is going to want you to leave your answer in set notation. So set notation is using the braces. Okay. All right. So number four, we're going to solve number four. So I'm not going to show my steps. I'm just going to tell you what we're going to do. So we have this equation, 16 minus 3x equals 25. Since the left side, I have a variable by itself, I'm going to leave it. So I need to get rid of the 16. So I am going to, subtract 16 from both sides. So 25 minus 16. Why did I write 36? So minus 3x equals, and then 25 minus 16 is 9. Then we divide both sides by a negative 3. So our potential solution is negative 3. Now, I am going to check this solution. So 16 minus 3 times our x value is a negative 3. And does this equal 25? So we get 16 plus 9, 25, and then 25 equals 25. That is a true statement. So x equals 3 is the correct solution. So we're going to write our answer in set notation. Okay. So -3. All right. Now I want you to try number 5 on your own. All right. So I'm going to pause the video in 3, 2, 1. Okay. So this is what you should have gotten for number, let's see, we worked number 4. So for number 5, you should have gotten 12, and I did check my answer. Now, I'm not going to ask you to check your answers, okay, but it is a good habit for you to get into. All right. Now for number 6, we need to be very careful because not only are we going to be distributing a number, but we're going to be distributing a negative as well. So be careful. So this is going to be 2x minus 6x minus 6 equals 1 minus 20x minus 15. Now, something that I didn't mention earlier in number 5 is notice that I did not start moving my variables to one side and my constants to the other. I cleaned up the left side and then the right side. And once I did that, then I started moving my terms around. Okay. So for number 6, we need to combine the 2x and a minus 6x. So that's going to give us a minus 4x minus 6 equals, then on the right side, we have 1 minus 15. So I'm going to write my x term first, minus 20x, and this is going to give us a minus 14. Okay, my next step now is when we're going to start moving terms from one side to the other. I'm going to add 20x to both sides. So positive 20 on the right is going to make this go away. So positive 20 minus 4, that's going to give us a 16x minus 6 equals negative 14. And then we're going to add a 6 to both sides. So minus 14 plus 6 is going to give us a negative 8. And then we end up with a negative 8/16. Now this can be reduced to 1/2. And if I were to plug this in, this would work. That would be my solution. Okay, I'm just not going to take the time to check it. Okay. But again, you do want to get yourself in the habit of checking your answers as you go. Okay. All right. Hopefully everything's okay with that. Now, when we look at these next two questions, we talk about clearing fractions and decimals. Now, really, anytime we have an equation with decimals, I usually don't worry about clearing the decimals because we have a calculator we can number crunch. However, let's go ahead and go through this because sometimes it does come in handy to get rid of our decimals. Okay, so here's what we're going to do. So I need to multiply everything through by a number that's going to get rid of my decimals. And so when we do that, we have to multiply the entire equation through by some number. So I'm looking at this 0.6, the 1.3, and then the 0.2. I'm not concerned with this 5x minus 8 because whatever this number becomes, then I'm just going to distribute. Okay, so what I need to look at are these numbers. Okay, so what am I going to multiply those numbers by in order to get rid of the decimal? Well, if you notice, that's one decimal place, this has one decimal place, and that has one decimal place. And that's the tenths place. So tenths, so that means that I'm going to multiply by 10. Okay, now let's say that this had, this was 0.6 and this was 1.3 and this one was 0.02. So this one decimal place, and that one would have been 0.02, which is 2 decimal places. Then I would multiply by 100. Okay, so you always multiply by the biggest number of decimal places that you have. But since these only have 1 decimal place, that's 10. 2 decimal places would be multiply by 100. If it was 3, multiply by 1,000. Okay, so when we do this, this is going to clean up really nicely. So if I multiply this by 10, we're going to end up with 6x minus 13 equals 2 times 5x minus 8. And again, all that did was get rid of those terms, those coefficients, okay? So we need to clean up each side. So I'm going to clean up the right side. So that's a 10x minus 16. Okay. Then I'm going to subtract 10x from both sides. So that's minus 4x minus 13 equals minus 16. Sometimes we get nice answers, sometimes we don't. So I'm going to add 13. So that's going to give me a negative 3. And then I'm going to divide both sides by a negative 4. So negative 3 divided by a negative 4. Now, I ended up with the fraction. So negative divided by a negative is a positive. So I ended up with the fraction, but my equation started out as a decimal. I can leave my answer as 3/4, but since this turned out, we started out with the decimal, I know that 3/4 is safe to turn into a decimal because it stops on its own. Okay, so that's the only reason why I would go ahead and turn this into a decimal. If I had a number that kept going on and on and on and on, I would have to stop it at some point, and then it would no longer be exact. Then I would leave it as a fraction. Okay, so you always want to reduce your answer, but do not rename. Okay, let me make that note. So, note, always reduce your answers or your answer, but do not rename as a decimal unless told otherwise. Okay. Okay. So be careful with that. All right. Now, number 8, we have an equation with fractions, and nobody likes to deal with this. All right. So what I'm going to do is I need to determine an LCD that will get rid of my fraction. So I have a 3, a 6, and a 2. So my LCD has to be large enough that 3 can go into it evenly, 6 can go into it evenly, and 2 can go into it evenly. So what we do is we take the bigger number, so the 6. So can 3 go into 6 evenly? Yes, that would go in 2 times. Can 2 go into 6 evenly? Yes, that would be 3 times. And then can 6 go into 6 evenly? And yes, that would be 1. So since that's the case, my LCD is going to be 6. Okay, so what we're going to do is we're going to take this equation and we're going to multiply everything through by 6. Okay, so 6 times 2/3 x minus 6. Let me go ahead and put these in parentheses. Minus 6 times 5/6 x minus 6 times 3. Now remember, even the numbers that do not contain fractions, you must still multiply those by your LCD. Okay, and then 6 times 1/2 x. And then at the end, if we have done this right, then that means that all of our denominators are going to be gone. Okay. All right, so here we go. So 3 goes into 6 2 times. 6 goes into 6 1 time. The 6 times 3 we're going to multiply. 2 goes into 6 3 times. And then the 6 times 5 we're going to multiply. So now we've got 2 times 2x, which is 4x, minus 1 times 5x is just 5x, minus 6 times 3 is 18, equals 3 times 1x is just going to give us a 3x, minus 6 times 5 is 30. Okay, now again, we're not going to start moving things around. Okay, so what we're going to do is clean up what we've got. So I can clean up these two terms. So that's going to give me minus x minus 18 equals 3x minus 30. Now I'm going to start moving my terms around. So I'm going to move my variable to the left. So I'm going to subtract 3x, which is going to give me a 4x minus 18 equals 30. We're going to add the 12 to both sides. I'm sorry, we're going to add 18 to both sides. So 30 plus 18. Hang on. Oh, this is negative 30. Okay, I knew something looked funny. Okay, sorry about that, guys. All right, so we've got negative 30 plus 18 is going to give us a negative 12. And so we're going to divide both sides by 4. So we get a 3. Let me box that in. So then our solution is going to be 3. And we can plug that back in and check, but it will work. Okay. All right. Now, the next thing we talk about are special conditions for equations. So we're going to identify a conditional equation, an identity, and a contradiction. So a conditional equation is true for some values of the variable and false for other variable values. So in other words, a conditional equation is everything that we've done so far. When we get an answer, we get a solution, that's a conditional equation. It means that that equation is true provided that x would equal, in this case, 3. In this case, x equals 0.75. This equation is true provided that x equals 12. This one's true provided that x equals negative 3. Okay, so those are called a conditional equation. A contradiction is an equation that's false for all values of the variable. So in other words, you would lose the variable So we're going to lose the variable and end up with a false statement. I'm going to abbreviate. Okay. An identity is an equation that's true for all real values of the variable for which the expressions in an equation are defined. So in this case, we start off the same as a contradiction. We lose the variable and end with a true statement. Okay, so remember, a contradiction, we end up with a false statement. An identity, we end up with a true statement. Okay, so let's look at number 9. So I want you to solve number 9. Go ahead and solve 9, 10, and 11 on your own, and let's see what you get. Okay, so I'm going to pause the video in 3, 2, 1. Okay, so this is what you should have gotten. So the first one gives us an identity. So we end up with 6x minus 12 equals 6x minus 12. So the left and the right side equal each other. That's an identity, which means it's the set of all x. Our solution would be the set of all x such that x is a real number. So I could plug any number I want and it would work. So that's an infinite solution. Number 10, we end up with x equals 0. That's a conditional equation. So this solution only works whenever we have 0 as a solution. Okay. And then number 11, we end up with the false statement. After we move our variables together, we lose the variables. I add a 6x to both sides, so they're gone. And that leaves me with 12 equals negative 12, which is not true. So that's a contradiction, which means we have the empty set. And that is a no solution. Okay, so those are the 3 types of solutions that you can get. Now, I do know that on your homework, some of your questions are going to ask what type of equation that you have. So make sure that you pay very close attention to your instructions, okay? All right, now we're going to start to get our feet wet by looking at some word problems. Okay, but these, I always say that there are nice word problems, then there are not so nice word problems. And these are nice word problems. The reason why they're nice word problems is because they just involve translation. Okay, now here's the rundown of what I would expect to see when you show your work. You want to identify the unknown variable or variables. Okay. Set up the proper equation. Solve the equation. And then you want to justify the potential solution. Okay. So that's what you're going to do. Now, when we identify our unknowns and then we set that up, we are going to do what's called, we're going to create a verbal model. And we're really going to get into that in the next section. Okay, so first it says, number 12, let X represent the unknown number. Okay, well, that's nice. They already told me what my unknown is. So we're just going to say that X is an unknown number. Unknown number. Okay. Then it says, write an equation that represents the given statement. Twice a number decreased by 7 gives the same value as the number increased by 2. Then find the value of the unknown number. Okay, so here's what I want to draw your attention to. This long statement is going to be our equation. It says twice a number decreased by 7 gives the same value as the number increased by 2. Okay, so let me get a highlighter to help us out with this. Oh, I think it's going to bleed through because this paper is really thin. Oh, well, it's a back page. So, okay, we're good. Okay, so we have twice a number decreased by 7. Okay, so twice a number decreased by 7. So that would be x is the number. So twice a number, we're decreasing it by 7. Okay. And then we have the part that says, trying to find another marker, gives the same value. That is my equal sign. Okay. It gives the same value as, gives the same value as the number increased by 2. So the number, which is x, and we're going to increase it by 2. All right, so let me just highlight. Twice a number decreased by 7 gives the same value as, that's your equal sign. A number increased by 2. All right, so there is our equation. Now, all we're going to do is solve it. Okay, so I'm just going to rewrite this. So I'm going to subtract an x from both sides. And then I'm going to add a 7 to both sides. Okay, now how do I know that this is right? Well, we want to check it. All right, so I for sure am going to check this. So we get that 9 is our answer. So we're going to have 2 times 9 minus 7. Does this equal 9 plus 2? 2 times 9 is 18 minus 7 equals 9 plus 2 is 11. So 11 equals 11. So that is true. So my unknown number is going to be 9. Okay. Oops, that was in blue. I meant to put that in black. So my unknown number is going to be 9. Okay, that's how that works. Okay, now let's look at 13. Adele's 2020 Mini Cooper gets 37 miles per gallon on the highway, 29 miles per gallon in the city. The amount of gas she uses, A, in gallons, is given by the formula, where C is the number of city miles driven, H is the number of highway miles driven. If Adele drove 58 miles in the city and used 5 gallons of gas, how many highway miles did she drive? Okay, now this seems like there's just a lot of information. Okay, so here's what I want to point out. This entire first sentence Hang on, I'm getting a ruler. So this entire first sentence is not something that we need to worry about. The only reason that this is here is this is information that was used in order to derive the formula that they gave us, the A equals 1 over 29C plus 1 over 37H. Okay, so we don't need any of this. Okay, so this information is used to derive the formula given. So I don't have to worry about any of that. Okay, but for my formula, notice that we have three variables. So we have A, which is the number of gallons. Okay. C is the number of city miles driven. H is the number of highway miles driven. Now, what did they give us? They said if Adele drove 58 miles in the city, so they gave us city miles, which is 58. Okay. And then they said that she used 5 gallons of gas, which is A. So this is 5. So for my formula, they have given us A, which is 5, and C, which is 58. And they want us to find out how many highway miles did she drive. So we just need to solve this. So this is going to be 5 equals, well, 58 divided by 29 is 2. Okay, so I can clean this up. I can add the 2 to the, or subtract 2 to the other side, which gives us a 3. And then when I solve for H, I'm going to multiply both sides by 37. Okay, so I'm going to flip my variables around. Oops, I don't know why I started this in blue. Okay, so this goes away. So I'm going to put H on this side. 3 times 37 is going to give us 100. Now, H stands for highway miles. So highway miles. And let me make a correction. I believe on word problems like this, when you solve, you're not going to have to put this in set notation because you're answering what is the actual value that you're looking for. Okay, so that's all you got to do. Only when you're solving an equation are you going to have to do that. Okay, the last thing that we look at are these literal equations. We're going to solve for a certain variable. So for 14, they want us to solve for x. So I'm going to treat everything else like a constant. So I need to get rid of this 2a. So that means I'm going to add 2a to both sides. So we get 10x equals 5a. 3a plus 2a is 5a. I'm solving for x, so I'm going to divide both sides by 10. Now, 5/10 can reduce to 1/2. So I can leave my answer as a over 2, or I can leave my answer as 1/2 a. So either one of these would be okay. It's the same thing. Okay. Number 15, this should look familiar. This is the equation of the line. If they want us to solve for y, that means they want us to put this in slope-intercept form. So I'm going to keep the y, that minus 5y, where it is. I'm going to move the 3x to the other side. Now remember, slope-intercept form is y equals mx plus b. So we put the variable, the x variable first. Then we're going to divide everybody by a -5. Since we're dividing by a negative, be careful, because that means your signs are going to change. So y equals, well, negative divided by a negative is a positive. So that's y equals 3/5 x minus 2. And that's your answer, okay? Now for 16, we're going to solve for z, but z is stuck inside that set of parentheses. So it's kind of like an onion. We have to start peeling it away. So the first thing that I need to do is get rid of the 3/2. Since it's a fraction, I'm going to multiply by the reciprocal, but I'm going to do that to both sides. Remember, whatever you do to one side, you do it to the other. So this is going to give us 2/3 a equals, well, now those are gone to just leave us with z plus 1. And since I need to solve for z, I'm just going to subtract 1 from both sides. So z is 2/3 a minus 1. And that's it. That's how that works. Okay. All right. So I hope this was okay. I hope everything went okay. If not, if you have questions, you can email me or ask me in class. All right. So that's all I've got for you for section 1-2. Bye-bye.